Hi, my name is Helena. Today I will show you the lung lobar quantification application from Hermes Medical Solutions. We have loaded a SPECT perfusion and ventilation scan and a diagnostic CT. By diagnostic CT I mean a CT where you can see the fissures in the lungs. You don't actually need the ventilation if you don't have it. The minimum data set is perfusion and CT. The first step is to fit the diagnostic CT to the SPECT. This means that you can use a separately acquired CT for this processing if you need to. I'm going to click this auto fit button and the application automatically tries to scale the CT to fit the nuclear medicine. This is the factor that it's chosen. If you think this is not quite right, we can adjust this very easily. I'm just rolling the middle mouse button to adjust that, and you can see that that changes the amount of stretch applied. Once we're happy, we can then line up our image. So let's choose the image and click and drag to line that up. We can also do a rotation if we need to. I'm just going to take the window down a touch to help with this. Clicking and dragging on the outside will rotate it around that center point. Okay, that looks great. Once we're happy with the alignments, we can right-click and set off the automatic lung segmentation. So this will work on segmenting the lungs. You can see that's the automatic organ segmentation tool that we have. Also available in this tool is liver, kidneys and spleen. For this application, just the lungs is what we need. After a short pause, the lung regions appear. We can check these. We can see here that there's something that we should change at this point. So let's click this region, choose the tool to edit with, and then we can just brush this bit away. This tool acts over multiple slices, so we can scroll and see how this looks. Okay, just a little bit left there to do. Okay, if we want to as well, we can just tidy up around the airways. Okay, let's say that we're happy with that for now. Okay, now we can go ahead to segment our lung lobes. Let's hide the fusion there. I'm going to zoom in to get a good view. We can right click and use this segment right lower lobe option. We get this really nice split tool. The way this works, you click and drag along the fissure that you can see. That then puts a plane through the lung that is persistent throughout the whole lung volume of interest on this right lung side. And as I scroll, I can see that the fissure actually starts to deviate away from that plane. So now at this point, we can redraw where the fissure is. There we go. So now the application will interpolate between those two planes that I've given it as we go. So it quite nicely follows that fissure now. Okay, once you're happy with this lobe, we can right-click to exit the region drawing tool. Let's move over to the next lobe in this right lung. So right-click and segment right upper and right middle lobes. Click and drag, so it's the same style of tool, just to make a split through this region. Maybe I could do that a bit again, because I didn't quite get that nicely following. Let's say that we're happy with that for now, and then we can right-click to exit. So that's the lobes created on the right-hand side. Let's move to the left. Find a nice slice where you can see the fissure easily. Right-click, lung lobe, and now we have segment left upper and lower lobes. And again, click and drag to define the fissure. Yeah, so we're happy with that for now. Right-click. Okay, and now we have the results ready for us presented in this table. So we can see it's automatically recognized the whole lung volumes, the split lobes on the right-hand side and the left side. We've now got the contribution of the perfusion. So those regions that we defined on the CT have been copied across onto the nuclear medicine image, and we have the contribution of the perfusion counts in each lobe, the ventilation counts in each lobe, and we also have the volume percentage and volumes in mils that's taken from the SPECT for the full results. Okay, finally, the last thing is just to write any comments if you want to, and then create a report. So this button here to create the lung lobar report. Okay. So the application is automatically populating a DICOM encapsulated PDF report with screenshots and with the results table. Also, we'll get those regions that we just created saved out in DICOM seg format. Now we can look at the report that's been created. The report contains information from the patient demographics, information from the CT image and the nuclear medicine images. We also have the results table printed out here. Some lovely 3D volume renders of those lung lobes. This can be useful for showing the surgical team. And then we have fissure prints here. So we're looking at the left lung. Really useful if there's somebody else doing the processing from the person who'll eventually report the scan, so they can see exactly where those fissures have been placed. And because we've got these regions saved out, it's actually quite straightforward to load those back in again and just edit these if we need to afterwards. The same available here from the right lung, so we can see the fissures that was placed to create those right lung lobes. That was a brief demonstration of the lung lobar quantitation application from Hermes Medical Solutions.